Yeah, okay. So we go for our last speaker, that is Professor Francisco Fraile. Currently, he is associated professor and senior researcher in the fields of digital manufacturing and civil effects manufacturing at Polytechnic University of Valencia. And he has conducted his research in, I'm sorry, I already said this. So he's going to present the last presentation related with the project AI-PRISM, and its title is AI-powered human-centered robot interactions for smart manufacturing. So please, Professor, all yours.
Okay. Can you hear me? Is the mic working?
Yeah, it's working. Yeah,
Okay, perfect. And I guess that you can also see my slides.
yeah, perfect. Thank you.
Okay, thank you very much for this opportunity to participate to this webinar. I enjoyed very much the previous presentations, and I'm going to present one of the projects we're working on, AI-PRISM, uh, for which I find strong synergies with Ultimate and all the previous presentations that I saw. So through the my presentation, I will emphasize those synergies. So here's a brief overview of the project. It's a Horizon Europe project that started in October 2022 and that ends in September 2025. And we have a very large consortium composed of 25 partners. I noticed that we have some partners in common with Ultimate, for instance, Robotnik and PIAP. And yeah, well, our main aim is to develop a human-centered AI-based solution ecosystem for manufacturing environments in where we will deploy AI-based solution to enhance the reasoning and perception capabilities of robot agents. And we have a very solid social sciences based. We want the whole solution to be very human centric. Now this slide highlights our main innovations and the main domains of research domains. So we have I mentioned it earlier already. We have a very strong human-centered robotics component and collaborative robotics component. We also have a intensive research works on data and AI. And social sciences, and also in open access to pilots and test before invest. And the main outcomes are highlighted here to the right. We are developing a collaborative robotics platform, which is very modular and that answers the needs of small and medium enterprises. And that includes the programming by demonstration paradigm to facilitate the programming of the robots, and also real-time communications infrastructure to enable a cooperation ambience. Within that cooperation ambient, the objective is to deploy AIs that support that enhance the capabilities of the robots, and also support the cooperation and the coordination between human and the robot agents. We have a very strong social sciences component. So all the developments are guided by social and human sciences. And another result is what we called an open access network of pilots, where other scientists or any organization that is interested in training or experimenting with our pilots can access them in a virtual environment. So more on this. Our this is our vision for this collaborative robotics platform. So we're leveraging Kubernetes and CI/CD, continuous integration and continuous delivery infrastructure to define what we called a catalog of modules. So in our vision, human robot collaborative applications are made of modules, for instance, integration modules to communicate with a specific robot hardware, and AI modules like models that are used to perform a specific task to solve a specific problem with AI. And the applications are composed out of those modules. So using these technologies, what we can do is either manually by the end user using an intuitive user interface, select these modules and install them in a distributed infrastructure, either on a on-prem data center in the factory, or in the fog, or in far edge devices that are close to the robots, or automate this process of deployment using leveraging annotations and rules, so that the applications can be discover automatically what are the resources that are available in a specific instance, and select the best modules to implement that collaborative application. Now, to enable these communications within this distributed infrastructure, we introduce real-time communications using technologies like software-defined networking to ensure the deterministic behavior of the network. And using those real-time communications, we can also add additional sensors to sense the collaboration ambient, and add additional context to the AIs. And yeah, and to facilitate the interactions with the human, we're promoting a no-code or low-code environments where we can use natural and natural interfaces like voice commands, or examples using kinesthetic programming by demonstration, or demonstrations in virtual environments to implement the robot programming, to learn from humans by example, to learn the tasks that will be delegated by to robots. So in a nutshell, this is the modular collaborative robotics platform that we're developing. Now I see that, yeah, for instance, these components that Rafia presented could be part of this catalog, or also the types of models that we saw. We see them as an independent components that build up applications, and that they can be easily combined with other modules that we're developing and used in this platform. Okay, so moving on, in this slide, I highlight what we referred to as this cooperation ambient. So enabled by sensors and real-time communications, as we saw in the previous slide, what we have is a humans and robots cooperating in a manufacturing environment. And these sensors, also those implemented within the robot, enable the provide the data needed to implement AI-enhanced perception, to add through these modules that I mentioned, provide the ability to better understand what's happening in the collaboration ambient, what we call activity understanding, who is interacting with the robot, and what are they doing within the collaborative task, and also to understand what's the status of the human operator. If is he experiencing any physical or mental discomfort, and so these perception abilities provide the input to take to other AIs that enhance the reasoning capabilities of the robot agents, their ability to take better decisions, to make better actions, and enable a more, say, smoother and interaction between and a human-friendly interaction with their human counterparts. Now, this happens both at the robot level, but also at the ambient level. So we also have perception enhancing modules that do not consider the immediate environment of the robot, but the larger collaboration ambient. So they have a wider perspective of what's going on, and those that information is also used by AI enhancing modules that enable the coordination and planning of actions within the ambient, and also implement prediction features that can also be used to improve reasoning, to make better decisions. So, and for the last innovation that I mentioned in the previous slide is Open Access Alliance. This diagram, I mean, this is still ongoing, but this under development. But this diagram highlights what we want to do. So basically, within the project, we have in total five pilots. I'll provide a brief overview of those in the next slides. But we want to provide a virtual, a digital twin of those pilots, and enable access to entrepreneurs, students, researchers, or programmers that want to learn or use those pilots. So in the what we call the network suite, those interested partners can learn, find the training materials to get the certifications needed to use those those pilots, and also schedule the use of the physical through these digital twin services, schedule the use of the physical infrastructure to conduct experiments, and the pilot owners they can approve these experiments and sign the deal so that they can also maximize the use uh, of those pilots. Now, this network is also opened for other third parties like entrepreneurs, students, or researchers that would like to add other virtual pilots, other physical labs to this network. Okay, so here also for the Open Access Alliance, it would be great if we can find some common grounds and cooperate if you're interested in this in accessing this or become part of this network. We'll be very happy to welcome you on board. Here, I'm going to provide a very brief overview of the different use cases. So the first one is focused on furniture. Um, uh, Particularly, we're developing a collaborative robotic solution to assist workers in the handcrafting process of painting furniture, design furniture. In the second use case, this is where we have a Vigo. We're developing a solution to support humans in the production of semiconductor components. In our third use case, we're focusing on robotizing some internal logistic processes in Athenian brewery, which are for different reasons unsafe and or non ergonomic. Basically, dealing with the preparation of materials for the brewing process, and also the management of empty bottles. And our four use cases focused on home appliances. In particular, we're developing a collaborative solution to test perform validation tests on hoods, on components for wide for home appliances. And finally, we have another use case with Keba, where we are automating the some processes related with the handling of PCB boards for performing the quality testing of those boards. Okay, so this is a vision of the pilots. Maybe later on the panel, if you have any, or during the QA, if you have any questions about those, I can provide further details. As for the, I also wanted to formally invite you to two forthcoming workshops that we have already approved. So we will be present at the European Robotics Forum in beautiful Rimini in March. We have a workshop there focused on human robot collaboration. And we also have another workshop in the forthcoming AISA 2024, which will take place in Crete. So if you're for this one, for the second one, if you, I mean, the agenda for the European Robotics Forum is pretty much closed. But if you'd like to, if you're attending the AISA conference and you find our workshop interesting and you'd like to participate as a panelist, we might still have time to consider it. And that's it. Here in the slides, you have our the contact info for our project in social media and also on LinkedIn. And yep, I'm now. This is the end of my presentation. I think we have a few minutes now to answer your questions if you have any.
Yeah, thank you very much for your presentation. It was really, really interesting. And thank you very much for letting us know for this conference and inviting us. For us, we will find some point of collaboration for sure. And yeah, we have a question. I think it's regarding one of the use cases asked by Michelle, is which kind of certification is considered?
I think you mean for the open access network. So
yeah, I think so.
At the moment, we're so for instance, imagine that we're dealing with a equipment, for instance, a robotic solution for inspection that requires certification, or that the training is for for instance, for training a specific robot model for a tool. So I mean, we're very open-minded about it, but we're focusing on training to use these resources that are shared in the platform, like the equipment and the robotic solutions.
Okay, thank you. I do have a question because since you are ending next year, so I guess when you started the project, the AI Act was not already approved. Do you have any impact, or are you foreseeing impacts regarding your working with the regulation of AI Act, or at the moment is something that is not affecting you?
No, of course it is. I mean, we're dealing with it in a additional work package that we defined on an amendment, and yeah, and that's one of the main synergies that I identify. Also, I mean, from because yeah, we would benefit from a closer collaboration with Ultimate in this sense, you know, to improve our response. So.
Yeah, I completely agree. Yeah, I don't know if there are more questions. No? Well, but thanks again, Francisco. And well, I love the turn to Michelle.
Okay, thank you.